Hey guys, my name is Reno, and today I'm going to be teaching you about midpoint and distance formulas. So first off, let's start off with the ruler postulate. So to find the distance between 2 points, x and y, or the total distance between them, z, we can use a ruler postulate. So the ruler postulate for horizontal distance is the absolute value of x2 minus x1, and the ruler postulate to find the vertical distance is the absolute value of y2 minus y1. This is mainly for when you're graphing points on a coordinate plane, but here it's represented on a line. So we have 2 points x and y. So this is going to be the x coordinate of the first variable, x, and this is going to be the x coordinate of the second variable, y. You're going to subtract x2 minus x1 and get the absolute value of that, and that's going to be your distance between these 2 points. Next, congruent segments and segment addition postulate. So, congruent segments. Congruent segments mean that there are 2 line segments which are of the same length. So, they are known as congruent segments. So, for example, if one line segment had a length of 4 meters and another one had a length of 5 meters, then they are not congruent. If one line segment had a length of 3 meters and another one also had a length of 3 meters, then they are both congruent. Segment addition postulate. So, there are two sentences right here, but they're just reverses of each other. If y is between x and z, then xy plus yz is equal to xz. If xy plus yz is equal to xz, then y is in between x and z. So if you're told that y is in between x and z, or you're given a diagram, then this is true. But if you're just given a formula or an equation like this, then this is true. So here is represented on a line. So there are 3 points on this line, x, y, and z. The total distance is xz. Since y is in between x and z, xy plus yz is going to give us xz. So there's a separate line segment right here, xy, and a separate line segment right here, yz. Alright, practice. Plot the following points in a coordinate plane: I, -2, 5, O, -1, 5, P, 3, 5, and R, 3, 6. Determine if I, O, and PR are congruent. Come back for the right answer. Alright, so now that you're back, alright, so first off, IO is equal to the absolute value of x2 minus x1. So here, the y coordinate does not change. So for both of these points, the 5 is constant, but the x coordinate does change, which means that this is a horizontal shift and not a vertical shift. So since it's a horizontal shift, we're going to use the absolute value of x2 minus x1. So x2 here is -1 and x1 is -2. So -1 minus -2 gives us -1 plus 2, which gives us the absolute value of 1. So IO is equal to 1. Now to find PR. So here, as you can see, the x coordinate stays constant and the y coordinate changes. So now, according to that, we know that this is a vertical shift and not a horizontal shift. So according to that, we can use the absolute value of y2 minus y1. Then we can plug in our values of 6 and 5. So 6 is y2 and 5 is y1. So then we get 6 minus 5, which gives us PR is equal to 1. Since both of these values are equal, we can say that IO is congruent to PR. Alright, now some more definitions. Midpoint and segment bisector. So midpoint, the point on the segment that divides the segment into 2 congruent line segments. So as you can see here, it's represented on a line segment. So there are 3 points, x, z, and y. Z is directly in between x and y, which then creates 2 congruent line segments, xz and zy. That's why it's called a midpoint, since it's in the middle. Now moving on to the segment bisector. As you can see here, the segment bisector, a point, line, ray, segment, or plane that bisects, which is another word for intersects, the segment at its midpoint. So we already know what the midpoint is. A midpoint is the point that's in the middle of a line segment. So according to the segment bisector, now there's going to be a point, line, ray, segment, or plane that's going through the midpoint. So here, this is represented in a diagram. There are 2 segments here, x, y, and AB, and Z is a middle point. midpoint. So AB is bisecting the original line segment XY at the midpoint Z. So this is going to be the segment bisector, and since it's bisecting the original line segment XY at its midpoint Z, it creates two congruent segments XZ and ZY. So they're going to be equal. Right, now here's a practice problem. In the design, DC bisects AB at point E, and BE is equal to 54.3. We need to find AB. Include reasons if you can. So reasons are just things that happen. So for example, here we're gonna write down formulas and everything. If you have the knowledge for that, and if you know what to write it down. If you don't, that's completely fine. Pause the video, try this out, come back, and I'll give you the answer. Alright, now that you're back, first let's establish some things. So AE is congruent to EB. Since DC bisects AB at point E, we know that AE is equal to EB. That's the segment bisector definition. Here we can see that DC bisects E and AB at its midpoint. So therefore AE is congruent to EB. Next, AB is equal to AE plus EB. That's a segment addition postulate. If one point is in between two other points, then the first segment plus the second segment created because of the point in the middle, they're both of them summed up together is going to equal the length of the original or the total line segment. So here it's going to be AE plus EB is equal to AB. Next, we're going to plug in our values, 54.3. Since we can see here that BE or EB is congruent to AE and BE is equal to 54.3, we can say that AE is also equal to 54.3. We substitute and then we get a final value of AB is equal to 108.6, which we're going to add. Okay, now going into the bulk of our section or the lesson today, midpoint formula. So the coordinates of the midpoint of a segment are the averages of the x coordinates and the averages of the y coordinates. The averages of the x coordinates are going to be the x coordinate of the midpoint, and the averages of the y coordinates are going to be the y coordinate of the midpoint. So here we can see it as x2 plus x1 divided by 2 and y2 plus y1 divided by 2. This is what we're going to be using to solve for the midpoint in some cases. Alright, now midpoint formula practice for you guys. If the endpoints of segment YT are y, -2, 4, and t, 6, -2, then find the midpoint O. Pause the video, use the formula that we just learned, come back for the answer. Alright, now that you're back, so we're given endpoints y, -2, 4, and t, 6, -2. We know the midpoint formula, so let's write that down. x2 plus x1 divided by 2, y2 plus y1 divided by 2. This O here represents the midpoint, and x2 here is going to be 6, x1 -2, y2 -2, and y1 4. So let's add these values together to get O. Midpoint O is 4 divided by 2, 2 divided by 2. So therefore our midpoint O is 2, 1 on the coordinate plane. Alright, now finally our distance formula. So if A and B are points in a coordinate plane, then the distance between them can be calculated by using the formula below. AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So if you're given 2 points on a coordinate plane and you need to find the distance between them, then we can just use this formula to find the distance. Alright, a small word problem for you guys. You have to walk to your school, which is point A, 2 miles west and 3 miles south. Once you get home, which is the origin, 0, 0, 0, you have to walk to the grocery store, which is 4 miles west and 5 miles north. What is the distance between the school and the grocery store? Plot these points on a coordinate plane and then solve for the distance between points A and B. And then come back for the right answer. So, on a coordinate plane, we're going to plot point A right here, which is -2 to the which is going to be point B. Sorry, it's not point A. It's going to be point B, which is a grocery store. So that's going to be -4, 5, -4 units to the left and 5 units to the north, which is going to be -4, 5, and then point A, which is the school, it's going to be 2 miles to the west and 2 miles to the south, representing -2 and -3. -2, -3. Alright, to find the distance between these points, we can use a distance formula. AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So x2 in this situation is going to be -4 and x1 -2, y2 5 and y1 -3. We're going to sum up these values. The negatives here cancel to give us a plus. The negatives here also cancel to give us a plus. Once we add those values together to get AB is equal to the square root of -2 squared plus 8 squared, then it's going to be AB is equal to the square root of 68. We get that by squaring these two values. We get 4 plus 64, which gives us 68, and then the square root of that, the square root of 68 is 8.25 miles. That is the distance between points A and B, or the distance between the school and the grocery store. I hope you guys enjoyed the video. I hope you guys thought that this was informational. Come back again for more informational videos like this.